Hi, I'm Jan. I'm the CTO of React Squad, and in this video I'm going to be answering the most Googled questions about React testing. For example, what is unit testing in React? How do you test components that do REST API calls? And how do you use ACT and when do you need to use ACT when you're doing component testing? Now we're going to kick things off with the question, what is a unit test in React? And when people talk about unit testing in React, they typically refer to the tests for helper functions or reducers or the React components itself. And they typically use one of two frameworks for that, either Jest or Vitest. These two libraries are the most popular. Jest was around a little bit earlier, but Vitest is a little bit faster. And then there's also a third one that I want to mention, which is kind of an honorable mention, called Rightway. In my opinion, Rightway is the best testing framework for beginners because it forces you to write good tests. And then once you have some experience with testing, then you can switch to Vitest and Jest, which are definitely a lot more powerful. Now we could move on to the next question here, but I want to dissect this because when it comes to React testing, the lines between the different types of tests get blurry. You have unit tests, you have integration tests, and you have functional tests. And again, the lines between these get blurry when you're talking about React tests. We're gonna look at this in detail as this video continues, but let's start with the strict definition for unit tests. Now, the strict definition for unit test is that a unit test tests a component or function, or basically the unit under test, in isolation. Let's look at an example so you know what it means to isolate something, right? So imagine you have a function called add, and this function takes in two numbers and returns the sum of those two numbers. This function is a pure function because given the same input, it always returns the same output, and this function has no side effects. And all pure functions are trivially easy to write unit tests for because by definition, you can isolate them easily. If you've never seen a test, they look something like this. You have a describe function that tells you about the component that you're testing or the unit under test. Then you have a test function that describes with prose text what is the behavior that you're testing. And finally, you have an expect function that you use to do some assertions to make sure that your components behaves as you expect it to do. Now, unit tests are perfect for pure functions, but if you have a function with side effects, then you better use integration tests. Integration tests test how multiple units interact with each other. They're also sometimes called collaboration tests, but integration test is basically the much more popular way to call these kinds of tests. I just wanted to mention collaboration tests so you know it. Well, let's look at an example for an integration test so you know how they look like. Imagine you have a function called requireUserExists that takes in a user ID and then fetches a user from a database, and then if the user does not exist, it throws a not found error. The requireUserExists function needs an integration test because it fulfills both of the criteria for functions or components to decide whether they need an integration test or not. The first criteria is, does the component or function consist of multiple other functions, right? Because you remember the definition for an integration test is that it tests how different functions or components or different units under tests interact with each other. And the second criteria is, does the function or unit under test have side effects? And requireUserExists both consists of two other functions, right? The one function that reads from the database and the other function that maybe throws if there's something going wrong, if there's no user return from the first function, basically. And the second criteria is that it also has side effects, right? Because both reading from a database is a side effect and potentially throwing an error is a side effect. And if you don't know what a side effect is, it is basically classified as interacting with outside scope. So as long as the function only interacts with inner scope, then it doesn't have side effects. But as soon as it influences outside scope, because, for example, it logs out something, it reads or writes to disk, or it even throws an error, then it contains side effects. Okay, so let's now take a look at how you can write an integration test for requireUserExists. When you write tests for any function or component that talks to a database or that talks to a REST API, basically for any unit under test that has side effects, you need to do one of two things. You either need to mock that side effecty behavior, or you need to clean up and set up the environment, or for example the database, before and after the test using setup and teardown functions. Now, if you don't know what a mock is, mock basically means replacing some part of the code under test with a test double that fakes the behavior. And mocking is a code smell for tight coupling, which really is a topic for another video, to be honest. So I'm not going to go into depth in this video, so subscribe to this channel if you want to have more advanced testing content. But because mocking is a code smell, I want to show you an example using setup and teardown functions. So create a function called setup that creates a populated user using a factory function and then saves that user to the database. And then it uses the onTestFinish hook to clean up the user, to delete it from the database once the test passes or fails. This function always runs. And as you can see, we're using methods again from Vitest because you can write integration tests and unit tests, both with Jest, Vitest, and even with Rightway. It doesn't matter. These frameworks are capable of all of these different kinds of tests. Then you use your describe function again to describe the require user exists function and write the first test, which should test that if there's a user, then it should just return the user from the database and not throw. And in the second test, you pass it an invalid ID, and now you expect the function to throw. So you can wrap it in a try-catch block and do the assertion in the catch block. You also need to write expect.assertions at the top of your function. This method tells Jest or Vitest that you expect at least one assertion to happen. Basically, every expect in your test block is a single assertion. And since we only have one expect block here, we expect one assertion to happen. You need to do that because if the require user exists function does not throw, then the catch block would never run. And then you would have a false positive. And by writing expect assertions 1 at the top of your test, if there's no assertion happening because the catch block doesn't trigger, the test will still fail, and in your test output you will see, hey, I expected at least one assertion to happen. So that's how you write tests for throwing code. And as you can see in the first test, it automatically sets up the database and cleans it up for you. Now let's talk about the third kind of tests called functional tests. Functional tests test your app from the user's perspective. And there are different ways to do that with React. On the one hand, you have React testing library, which works together with the aforementioned frameworks, or you're using browser testing tools such as Playwright, Cypress, or Selenium. React testing library allows you to fake render components. And in order to do that, you need to also use a tool like JSDOM or HappyDOM that mocks the browser environment in your Vitest, Jest, or Rightway tests. And you're going to see how to do that later. But let's first also talk briefly about the browser testing frameworks or end-to-end testing frameworks, because they actually run your app in a real browser. So Playwright, Cypress, or Selenium spin up a real browser, run your app like a real user would run it, and then that also makes it usually so that the app also talks to real database or does real API requests, right? You can also mock those things, and you're going to learn how to do that later and also in future videos. But for this video, we're going to just talk about the basic differences between these two strategies. And the reason why you want to use React testing library is because these tests give you fast feedback. They run together with your unit tests and your integration tests, and you can have a watch script running, and basically every time you hit save, your tests run and you get immediate feedback. Because everything is mocked, everything is super fast. The end-to-end tests with Playwright and Cypress, they're a little bit slower. Sometimes end-to-end tests can also be flaky if you do it wrong. I'm going to teach you how to do it right, not in this video, but in a future video. But the main trade-off or the benefit of end-to-end tests and spinning up an actual browser, talking to an actual database, etc., is that it gives you a lot more confidence, right? Because the app is actually used the way that you use it. Sometimes JSDOM and HappyDOM, even though they're great mocks, sometimes they just behave differently, right? And then there are also differences in browser behavior. Safari, Firefox, Chromium, they all behave differently. And with end-to-end testing frameworks, they allow you to spin up real browsers and get the real browser behavior. And you also have access to APIs that are just straight up not mocked. For example, if you ever build something with WebRTC, right, then all of those real-time libraries are usually not included in HappyDOM or JSDOM. Okay, so let's look at a functional test with Playwright against example.com. You visit a page, in this case example.com, and then you make sure that on that page there's the correct heading, some correct text, and also the correct link. You can also click around and fill out forms and scroll, but more on that later. So when you're talking about tests for React, then the lines between unit tests, integration tests, and functional tests get very blurry. Take a look at these tests for your reducers. When you write tests for your reducers, you usually test selectors, actions, and reducers all together, because the actions don't make sense without the selectors. They're like pairs of getters and setters. So is this an integration test or is this a unit test? Because this is also for the unit of each selector. But so much different units are interacting with each other. The same is true, which you're going to see later, for tests for React components. If you use React testing library, then you interact with the component from the user's perspective. So you could argue it's a functional test. But if you only test one component at a time, then you're also kind of testing this component in isolation. So is it a unit test? And you're mocking with JS DOM or Happy DOM the browser environment. So is it an integration test? And with tests for Playwright and Cypress, it also gets a little bit complicated because it's technically speaking both an integration test, because in order to run your app fully, you're also running your loaders if you're running a Remix app, right? Or you're also running your form actions if you're running a Next.js app. So you could argue it's an integration test, but at the same time, you're running it from the user's perspective. So it's a functional test, right? So the lines are blurry. And the only thing that I want you to really take away here is when in Rome, do as the Romans do. In other words, if your team calls something integration test, then just stick with their definition. You now know all of the strict definitions, but just be flexible about this and just go with whatever your team calls your tests. Now let's move on to the next question. How to do unit testing in React. Usually my videos are designed so that you can code along from start to finish, but this video, the beginning was a little bit different. But if you already have an ongoing project, I'm going to give you now the instructions that you need to execute if you want to enable unit testing in your project. So, install Vitest. For the latest instructions on how to set up Vitest, in case you're watching this video 1, 2, 3 years after it has been released, you might want to check out their documentation. But for now, this video is definitely up to date. So, the next step that you want to do is add a testing script to your package JSON. To verify that you have set up Vitest correctly and that your configuration worked, create a new file that contains a quick sanity check test. In this test, you just assert that true is true, and then you can run your tests with npm run test, and obviously your test should pass because true is true. Now install React testing library together with some other packages such as Happy DOM and some Vite plugins. And now either tweak your existing Vite config, or if you're not using Vite, then create a vitest.config.mts file. And in this file, you configure the environment to be Happy DOM. You also link to a setup test environment file. Now create up a setup test environment file. This file contains some configurations that allow you to have some special assertions available on your expect object, and it also configures React 18. Now you are ready to write component tests with React testing library. What does testing a React app with Jest do? Well, Jest is a test runner. It gives you certain methods that you can use to write your tests. Describe, expect, test, right? You've seen them all earlier. We've been using Vitest because Jest and Vitest have the same API, but Vitest runs faster. So everything that you learn here is also applicable to Jest. But using Jest or Vitest alone is not a good way to write tests for React apps. You can do that, but the tests are not going to be very good, which is why something like React testing library is around, which you've set up in the previous chapter. React testing library, together with Happy DOM, mocks the browser environment for you and then allows you to simulate user interactions, such as clicks or scrolling, all of those good stuff. So React testing library, together with Jest or Vitest, gives you confidence that your app works as expected when your user uses them. How to run React testing library. If you followed the instructions from the previous 2 chapters, then you should now be good to go to write your first test together with Vitest and React testing library. So import render and screen from testing library/React. Create a function component called greeting that just renders some stuff, and then write a test for it. In this test, you use the render function to render your greeting component, and then you use the methods on the screen object to query the DOM for the elements that you expect to be rendered. If you're working in an old project that still uses class components, you can do literally the same. Here's how that looks. Just create a class component and then write some tests for your class component and make sure that it renders what you want it to render. In other words, everything that you learn going forward about React testing library is applicable to you no matter if you're using function components or you're using class components. I also want to take this opportunity to point out the blurriness of test definitions one more time in context. If you go back to the previous example for the function component, you see that the assertions are being made using getByRole and getByText, which means that in your test you interact with the component like a user would, making it a functional test. At the same time, this component doesn't even take in any props, right? You cannot isolate it even more. Like, it's as isolated as it can be. So technically speaking, this is also a unit test. And that is what I meant earlier, right? The line is blurry. Is this a unit test? Is this a functional test? You know, maybe we could call it a Schrödinger's test because it is both at the same time. How to test a function in React testing library? So this question is a little bit confusing because it depends on what you mean, right? So if you mean with this question a function component, then just rewind this video 2 minutes because we just showed you how you can test function components. If you're talking just about functions in general, then you don't need React testing library for that, right? Because in the beginning of this video, you saw how you can test functions like pure functions or functions with side effects using Jest or Vitest. If you're talking, however, about functions passed as props to your React components, then you need to mock them, because then you can do assertions on those mocks about if they function have been called by your component as you expect them to be called. So the next question is how to mock function React testing library. Both testing frameworks, Jest and Vitest, give you a mock function. With Jest, it's called jest.fn, and with Vitest, it is called vi.fn. In other words, React testing library has nothing to do with your ability to mock functions. Your test runner is the one that gives you the ability. Now, when you call a mock function, it stores its arguments, return value, and instance. And then you can make assertion on that mock function. Let's look at an example on how you can mock by looking at how to test a button in React testing library. Create a new button component. If you're using TypeScript, make sure that you correctly type your onClick handler using the mouse event handler. Then mock the onClick handler in your test and pass it as a prop when you render your button component. Now you can grab your button_by_role and directly call the onClick event on your button element. This will trigger the mock, and then you can assert that it has been called. There's also an alternative way to do this using FireEvent from React testing library. The difference between button.click and FireEvent.click lies in how they trigger the click event. Button.click directly calls the DOM elements click method, bypassing React's synthetic event system and only firing the click event. In contrast, FireEvent.click simulates the click event using dispatch event, integrating with React's event system, but still only triggering the click event without intermediate events like mouse down or focus. For more realistic user interactions that actually trigger things like mouse down and mouse up when you click, install the user event library. Then import it in your test, and in your test at the top of your test, call its setup method. This will set up a new test user. Notice how the test is now async, because when you click using this user, you need to await it. And you need to await it because this user will now actually trigger all of the different events that are related to a click. Mouse down, mouse up, and when you type key down, key up. And there will be a tiny delay between those different interactions, because in the real world, when you type, you're also not instantly triggering all the buttons, right? It takes some time for you to press stuff. And user event mimics this behavior. If the interaction with your React component changes some internal state, and this internal state is reflected in what gets rendered from your component, then you do not need to mock to verify that your button clicks work correctly. Here's what I mean. Create a new component that has some state, some counting state, and you increment this state whenever this component is clicked. Now, when you render this component, then you set up everything that, like you're used to from the previous examples, but after you clicked, instead of asserting on the mock, you assert that the correctly incremented number gets rendered. And in my opinion, this is a lot cleaner than mocking. So whenever a component exposes internal state, then you want to make your assertions on that. And also, in summary, you want to use user event over fire event, or just directly calling the respective event on your element, because that gives you more certainty that the component works as you expect, because it closely resembles how the component works in the real world. How to debug React testing library? Well, React testing library exposes a debug method on the screen object. So here's a test, And you're going to use screen.debug in two different ways. The first one, just calling it without any arguments, makes it so that it logs out the whole component tree. Notice how body and div are wrapped around the thing that we're actually rendering in our test. So React testing library always wraps an additional body and an additional div tag around your component tree. But you can also pass arguments to screen.debug. And then screen.debug will only print out the node that you're trying to print out. So that allows you to debug certain selections in your component tree. If you want to debug clicks, then you can just do that how you're used to with console.log. Here's how that looks. You can just write the console log in the callback function of your onClick handler. And the rest of the test stays like you're used to do it. And when you now run your test, you will find the output of your console log in your test output. So in other words, if you want to debug stuff like useEffects, onClick handlers and stuff like that, you can just sprinkle in console logs and see them in your test output. How to mock API, React testing library? Well, in order to do mocks for API requests of your React components, you usually want to use MSW. MSW stands for mock service worker. Install it in your project. And now you can write a test for a function component that just fetches some user data called fetcher. Your fetcher component has a button, and when you click this button, it makes an API request to a placeholder API and gets back a user, which it stores in its state. To mock the API request, you use setup server from MSW, and you can define the response that the mock server should send. What's happening here is that your API request will get intercepted, and MSW will just respond with whatever you tell it to respond with. This is useful for two reasons. The first one is that you are not doing the actual API request to the server, which is both faster and cheaper, right? Because maybe with the normal REST API, it isn't too obvious why it's cheaper, but imagine that you're talking to a blockchain, right? You definitely don't want to do a transaction on the Bitcoin blockchain or whatever blockchain is your favorite blockchain, right? Whenever your tests run, because you will run out of funds very, very quickly. So mocking saves costs and time, but mocking also allows your test to be deterministic. So what if the API returns like a certain timestamp or certain random data, or maybe the data on the server gets deleted or changes its shape, right? Mocking allows you to make the response of your API deterministic because now you control it in your test, in your own code base. To integrate MSW with a test runner, use before all, after each, and after all hooks to set up the following steps. Start mocking before tests begin by using server.listen. Reset request handlers between tests with server.reset handlers, and restore your native request modules after the tests finish using server.close. When you now just write a test that uses the user event to click a button that will then fetch the user, your mock server will reply instead, and you can then assert that the correct thing gets rendered. If you want to test whether MSW works correctly, just comment it out and see that the response from the actual placeholder API is different from the data that you're mocking. But yeah, if you run these tests, you will see them pass. How to test dropdown in React? Well, to test the dropdown, you need a dropdown. So create a dropdown component. Your dropdown component renders just an HTML tag with a label and a select and some options. But if you have a dropdown component from your favorite component library, what you're about to learn will work the exact same way. So use user event again in your test, and then use the select options method to select an option from your dropdown, and then just make sure that the correct option is in your user interface. It is really as easy as that. How to test useEffect in React testing library? Well, before I answer that, let me quickly say that, did you know that React renders any component twice? So your useEffect runs twice in development mode, in strict mode, in React 18 and 19 and higher. But yeah, many people are using useEffect wrong. If you want to see a video on that, let me know in the comments. Okay, so let me answer the question. A good example to see how you can test useEffect in React testing library is, for example, for an offline indicator component. Your offline indicator component uses useEffect to track the online status of your user's computer. It hooks into the event listeners on the window object and then sets the state depending on what change just occurred, and then it just renders the current online or offline state. In the tests for this component, you just do everything like you used to, but the special thing here is that you dispatch event on the window object to falsely trigger online or offline events on the mocked window object from HappyDOM. And these calls to dispatch event are wrapped in act. I'm going to be explaining act in the next question, but I want to point something else out here. This component adheres to a principle by Kenzie Dodge called avoid testing implementation details. I personally have seen it or learned it from Kenzie Dodge, even though maybe someone else brought it up first, but for me, Kenzie Dodge really made it famous in the broader React community. Now, avoiding testing implementation details means that you as a developer in your test, you don't get any special access to the React component. You just observe its outside behavior. And if you adhere to this principle, it really makes your components resilient to change. The tests of your components resilient to change. Because when you change the inner state management, for example, in the earlier test that you saw with the button, where you're using useState and then you incremented account, if you were to change that from useState to useReducer, if you adhere to the principle of avoiding testing implementation details, then your test still passes if the behavior is the same. Whereas if you are tightly coupled to the internals of how your component works and you change its internals, even though the behavior is the same, suddenly your test fails, and that shouldn't happen. So it's a very important principle. And if you want to learn more evergreen principles, watch my video, Master Testing Keys, I think like 12 keys to master testing in JavaScript or something like that. Can't remember its name, but it's a great video. And if you watch it, you will learn the test desiderata principles by Kent Beck explained with examples in JavaScript. Okay, let's now talk about act and the next question, which is React testing library, when to use act. In the previous tests, you used act to simulate the online and offline events. And React handles its updates asynchronously. That means that when React triggers a state update, it doesn't necessarily apply those changes to the DOM directly. And act does exactly this. It forces React to apply its changes to the DOM so that you can then make your assertions. When you call something like fire event or user event, those libraries already use act under the hood automatically for you. But since window.dispatch event is a custom event, you need to use act to force those DOM updates. How to test hooks in React. You can test hooks without using them inside of a component. To demonstrate that, extract the logic from the offline indicator into a custom hook. Your custom useIsOffline hook is straightforward. It does the exact same as your component did earlier, but instead of rendering a diff, it just returns a boolean whether the component is offline or not. And then, in your test, you can use the render hook method from testing library React. This method exposes a result, and on this result, there is a current property. This current property is similar to ref, if you've ever used the ref in React, and it holds the most recently committed value. The rest of your test is exactly the same. You just use act to dispatch the events, and then you make the assertions on the current value on the result. How to do end-to-end testing in React? Well, this is a little bit of a trick question, because by definition, end-to-end tests run your apps in a real browser, right? You spin up a real browser, you talk to the real database, you talk to a real API, and it doesn't matter whether you're using Cypress or Selenium or Playwright, all of these end-to-end test frameworks do not care what you are using. So asking how to do end-to-end testing in React doesn't matter, because you can write the same test and you could swap out the implementation detail of the framework, right? You could swap out React for Angular or Vue, and you wouldn't even have to touch your test. Let me show you another example, just a test written against Wikipedia, and you can kind of imagine how you could create that Wikipedia page with any framework and it wouldn't matter. Now in this test, you just visit Wikipedia and you spin up a real browser, right, because it's a Playwright test, and then you type in Playwright, I wanted to make this test very meta, and you make sure that Wikipedia returns its correct results. And Wikipedia is probably also talking to its real servers, which makes this an end-to-end test. But the point here is that you don't know what Wikipedia is written with, right? Maybe they're using native HTML, maybe they're using Vue, Angular, React, doesn't matter. This test is independent of the framework, which makes this question kind of nonsense. Thank you so much for watching. I love you very much. If you learned something, subscribe to this channel for more advanced JavaScript content, and then go and watch this video next. Peace.